We're going to solve your 10 CBSE mathematics board practice problems. So let's start to solve, guys. The first question is, prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus of cos theta is equal to tan theta. People, here I'm gonna solve every question faster as much as I can so that I can finish every question in a short time span. Okay, so so how you can solve this question is, just listen to me very carefully. In the LHS, just let me take your LHS. So in LHS I'm having sin theta minus 2 sin cube theta by 2 cos power 3 of theta minus cos theta. So in this particular left hand side, on both numerator and denominator, I can take your sin theta common in the numerator, so that I will get it as 1 minus 2 sin square theta. Correct or not? And same like that, in the denominator you can take your cos theta common. Okay, so when I will get your denominator as 2 cos square theta minus 1. Correct or not? This is something we will get when I take your sin theta common in your numerator and your cos theta common in your denominator. Okay, so that is what I am doing here. Now after this particular part that I circled is nothing but your tan theta. So I can write this as LHS nothing but sin theta by cos theta is tan theta. Then times of, listen very carefully. Can't I write these two expressions that is in your numerator and denominator as 1 minus of, listen very carefully, sin square theta, then bracket, then minus of sin square theta, and your denominator as cos square theta plus of cos square theta minus 1, then the bracket. Can't I write like this? Think carefully and say, just in splitting is minus 2 sin square theta as minus sin square theta minus sin square theta, and your plus 2 cos square theta as plus cos square theta, then plus cos square theta. Why I am doing like this? Just observe the term inside the small bracket. That is 1 minus sin square theta and cos square theta minus 1. Because here we can use your Pythagorean identity which you guys learned in your trigonometry. Okay, so here I can write the same LHS as tan theta times of 1 minus sin square theta is cos square theta, then minus of sin square theta. Okay, so 1 minus sin square theta cos square theta minus of sin square theta, then divided by cos square theta plus of what I am having? I am having cos square theta minus 1. We know that your 1 minus cos square theta is sin square theta. Then what will be cos square theta minus 1? That will be minus of sin square theta, just by multiplying minus 1 on the both sides. So cos square theta minus 1 will be minus of sin square theta. Very simple, because we know that your 1 minus cos square theta is sin square theta. So cos square theta minus 1 will be minus of sin square theta. So now I can cancel these two terms. Therefore in the LHS I am getting tan theta. And what is given in the RHS? Here also tan theta. So just write it in a statement form, and therefore hence proved. As your LHS is equal to tan theta, which is equal to RHS. Okay, so this side ends proved. Now let us move on to our next question. The next question is, if sin theta plus cos theta is equal to root 3, then prove that your tan theta plus cot theta is equal to 1. So people, whenever you see the question of this kind, just try to use the information given. That's nothing but your sin theta plus cos theta is equal to root 3. Just use that and get a particular equation from that. Therefore, you can use that equation to prove this particular equation. Okay, so what I'm gonna do is, In the question is given that your sin theta plus cos theta is equal to root 3. Think what identities we know. We know that your sin square theta plus cos square theta is equal to 1 and your 1 plus sin square theta, those kind of identities are also there, but those are all deleted. Only sin square theta plus cos square theta is equal to 1 is there. So how can I arrive to that particular identity? I can arrive by squaring on both sides of the equation. That is what I am going to do now. So I am going to square on both sides of the equation. Okay, so by squaring on both sides of the equation, in the LHS I will get it as sin square theta a square plus b square plus 2 times of a, that is sin theta, b, that is cos theta, which is equal to root 3 square. Root 3 square is 3. Okay, so now I can write the same expression as sin square theta plus cos square theta is equal to 1 Pythagorean identity, then plus of 2 sin theta cos theta is equal to 3, which implies that your 2 sin theta cos theta is equal to 2 by taking 1 to the RHS. Therefore, this 2 I can cancel out. From this, I got to know that your sin theta times of cos theta is equal to 1. Now, this is the equation. This is the equation we got to know. So just use this as a hint to prove this. Okay. So let me keep this equation here. Sin theta times of cos theta is equal to 1. Let me keep this as some equation 1. Okay, so this is the methodology of solving any question of your board exam, right? So do the same like what you do earlier in your pre-boards. Okay, so that is what I am also doing it, but you need to do it in a brief manner. So now I got to know that your sin theta times of cos theta is equal to 1, and in this question they are asking us to prove that your tan theta plus cot theta is equal to 1. People, so this tan theta plus cot theta, just solve the LHS of this particular equation. So this tan theta I can write it as sin theta by cos theta, and this same cot theta I can write it as cos theta by sin theta. Correct or not? So now when I take LCM, I'll get it as sin theta into sin theta is sin square theta, then plus of cos theta into cos theta, that will be cos square theta, divided by sin theta times of cos theta. Correct or not? Just by taking LCM. Now people, we know that your sin square theta plus cos square theta is 1 Pythagorean identity. Then divided by sin theta times of cos theta. Do you know the value of that? Of course, yes. By using this, I found out that your sin theta plus cos theta is equal to 1. So I will get the expression as 1 by 1 is equal to 1 by equation 1. You need to write like this. Every steps are very important. So hence your is equal to 1. So therefore it's proved, hence proved. Okay, so that's all about this question. Let us move on to the next one. Our next question is, prove the following identity, that is sin cube theta plus cos cube theta divided by sin theta plus cos theta is equal to 1 minus sin theta times of cos theta. So people, just by observing this, you can understand that in the numerator I am having sin theta whole cube plus cos theta whole cube. Correct or not? That is something I am having in the numerator now. So from this I was able to know that I need to use your a cube plus b cube identity, nothing but a plus b into a square minus ab plus b square. Correct or not? This is the identity that you guys are already familiar with. And same like that, we have a cube minus b cube. That is nothing but a minus b into a square plus ab plus b square. Correct or not? So these two identities you are already studying in your class 9th. So just use this over on your numerator and then the question is done. So here I can use your a cube plus b cube identity where your a is sin theta, b is cos theta. So I can write this as a plus b, that is sin theta plus cos theta. I'm just solving out your LHS. Okay. So this LHS I can write it as, okay, so sin theta plus cos theta is a plus b times of a square sin square theta minus ab, that is sin theta cos theta, plus b square, that is plus cos square theta, divided by, this is what I am having now. So now I can cancel out these two terms. So therefore I can write your LHS as sin square theta minus sin theta cos theta plus cos square theta. So this sin square theta plus cos square theta will be 1. Therefore I will get it as 1 minus sin theta cos theta. So that is what I am having an RHS, which is equal to your RHS. Hence proved. Okay, so very easy one. So just use the basic concepts, basic things that you guys learned in earlier grades. Just communicate with each other and make and try to solve the question, and that is why you need to get the idea to solve it, because these questions are very easy. Just if you solve many questions of many external books like addition, you will become better. Okay, this is how we need to solve this one. Let us move on to the next one. Our next question is, if 4 tan theta is equal to 3, evaluate the value of 4 sin theta minus cos theta plus 1 divided by 4 sin theta plus cos theta minus 1. So people, this is a very easy one, very easy. If 4 tan theta is equal to 3, I would say that your tan theta is equal to 3 by 4. Write with steps, that's very important. Okay, so tan theta is equal to 3 by 4. This is what I can get from here. So from this, just draw a triangle, right angle triangle. So here, let this angle be theta. This is your right angle. And now it is said that your tan theta is equal to 3 by 4. That means your opposite is 3 and adjacent is 4. So from this I got to know that your opposite is 3 and adjacent is 4, because your tan theta is opposite by adjacent. So therefore I will say that your hypotenuse is 5 using your Pythagoras theorem. And now if tan theta is equal to 3 by 4 and I was about to draw the figure, I can draw the figure or the triangle in which all the 3 sides are included. From this I would say that your sin theta will be equal to opposite by hypotenuse, that is 3 by 5, and cos theta will be equal to adjacent by hypotenuse, that is 4 by 5. Correct or not? Just use this in this particular expression and get out the value. That will get us 4 times of 3 by 5. Then minus of cos theta is minus of 4 by 5 plus 1. Then divided by 4 times of 3 by 5. That is 4 times of sin theta plus 4 by 5 minus 1. This is how we need to solve now. So therefore, I will get the 4 times of 3 by 5 is what? 12 by 5. 12 by 5 minus 4 by 5, 8 by 5. Divided by 12 by 5. 12 by 5 plus 4 by 5, that will be 16 by 5 minus 1. So therefore, I get it as 8 by 5 plus 1, that is 8 plus 5 by 5, that is 13 by 5, divided by 11 by 5. Okay, Just solve it out, 5 cancel. Therefore, we'll get the value of this particular expression as 13 by 11. Therefore, this is equal to 13 by 11. That's why I need to solve. Just use the particular hint given in the question. This 4 tan theta is equal to 4 tan theta is equal to 3. From that, I can say that your sin theta and cos theta values I can just find out. Just use those values in this particular expression and get the value, which is 13 by 11. This is 13 people. So that's all of this question. Let us move on to the next one. Our next question is, find an acute angle theta when cos theta minus sin theta by cos theta plus sin theta is equal to 1 minus root 3 divided by 1 plus root 3. This is the sample paper question. Very easy one. So just by observing this, what you can say is, I am having cos theta minus sin theta divided by cos theta plus sin theta. So here, what I am gonna do here is, just observe one thing. In the RHS, I am having 1 minus root 3 by 1 plus root 3, which makes me to understand that, which makes me to realize that this cos theta and the cos theta terms on both numerator and denominator, I should make it as 1. How it's possible? Divide your cos theta on both numerator and denominator. So when I divide, I will get it as, I will write here. Okay, so this is what I am doing. Therefore, when I divide your cos theta on both numerator and denominator, I will get it as 1 minus sin theta by cos theta. It will be tan theta. I will write it as expression itself. This is what I will get now when I divide your cos theta on both numerator and denominator. When I divide your cos theta on numerator, this is something I will get. On denominator, this is something I will get. Therefore, I can write the same statement as cos theta by cos theta is 1 minus sin theta by cos theta is tan theta. I'm just solving our LHS, okay? That is what I'm doing here. Then divided by cos theta 1, then plus of sin theta by cos theta, that is 1 plus tan theta. And the question, it is given that this expression is equal to 1 minus root 3 divided by 1 plus root 3. Just observe your LHS and RHS. From observing the equality or the superimposition of these two particular expression on your LHS and RHS, I would say that this implies that your tan theta is equal to root 3. That is only possible when your theta is equal to pi by 3. So your theta is equal to 60 degree. So that's the answer for this question. Okay. Theta is equal to 60 degree. That's all of this question. Let us move on to the next one. The next question is, prove the following that tan power 3 of theta divided by 1 plus tan square theta plus cot cube theta divided by 1 plus cos square theta is equal to secant theta times of cos theta minus 2 times of sin theta cos theta. People, this is a decent question. Not like the question that we solved few minutes before. This is a decent one because you need to get that idea. That is what is very important. But it's really easy. But you need to use your brain to solve this. So what you need to do is listen. It's very easy, people. It's very easy. So in this particular question, what I'm gonna do is, let me solve your LHS. In LHS, this is something expression I'm having. Okay. So what I'm gonna do is, can't I write your tan power 3 theta as sin power 3 theta by cos power 3 of theta? Think carefully and say, can't I write like this? Very basic things, and you guys are aware of this. And your denominator, you can write it as 1 plus sin square theta by cos square theta. I can write your tan square theta like this now. Very simple. And same like that, I can write your cot power 3 of theta as cos power 3 divided by sin power 3 of theta, then divided by the whole divided by 1 plus cos square theta, which will be nothing but 1 plus cos square theta by sin square theta. So something I will get when you solve your LHS in this particular method. Very very simple method, just writing a ratio as some other form. Very basic things you guys learn in your 10th standard. So now from this I can write as LHS as, from this what you can do is, listen very very carefully. Okay. So now in the denominator for this particular expression, take LCM. When I take LCM, I'll get it as cos square theta plus sin square theta divided by cos square theta. Correct or not? Correct or not? This is something I will get in denominator when I take your LCM for this particular expression. Same like that, here also take the LCM. So the numerator will be same only, that is cos cube theta by sin cube theta divided by 1 plus cos square theta by sin square theta. Just take LCM, therefore you get it as sin square theta plus cos square theta divided by sin square theta. This is something I will get when I take LCM on a denominator. Now let me rub these things. Now this same LHS I can write it as, see, sin cube theta divided by theta, then divided by the whole divided by cos square theta plus sin square theta divided by cos square theta. This cos square theta plus sin square theta is nothing but here one Pythagorean entity. Correct or not? And same like that, here your cos square theta plus sin square theta is 1 Pythagorean entity. Okay, so now sin cube theta by cos cube theta by 1 by cos square theta, just by taking reciprocal I can write it as sin cube theta by cos cube theta times of cos square theta, then plus of cos cube theta by sin cube theta times of sin square theta. 1 by sin square theta goes to the numerator, that will be times of sin square theta. Okay, so just cancel out one cos square theta, and just cancelling out, therefore one cos theta will be left out. Here also one sin theta will be left in the denominator. Okay, very very simple concept, very very simple concepts. That is what I am doing here. Therefore your LHS will be nothing but sin cube theta by cos theta plus cos cube theta by sin theta. So therefore I will get it as, just take LCM again. So sin theta into sin theta will be sin power 4 of theta plus of cos theta times of cos theta will be cos power 4 theta by sin theta cos theta. Okay, so very simple. Just I am taking LCM for the sin theta by cos theta plus cos theta by sin theta. This is something I will get, I will arrive. Now what you will do? Now this is multiplication, people, sin theta and cos theta. Now what I can do, think carefully and say, any idea? Any idea? I think you guys can't get idea from this step, but what I'm gonna do is, this sin power 4 theta plus cos power 4 theta I can write in some other way, because we know a plus b whole square is a square plus b square plus 2ab. So this particular expression if I need to get, I will write here. Okay, I will explain it briefly. I can write here sin square theta plus cos square theta the whole square as a square, that is sin square theta whole square, that will be sin power 4 theta, then plus of cos square theta whole square will be cos power 4 theta, then plus of 2 times of a into b, that is 2 sin square theta cos square theta. Correct or not? This is something I will get now. What is your sin square theta plus cos square theta? 1 Pythagorean entity. So 1 square will be 1 only. So your LHS is 1 for this particular identity. And now for getting this particular term, for getting these two particular terms, I can write your sine per 4 of theta. Wait. Cos per 4 of theta as 1 minus 2 sine square theta. Correct or not? Think carefully and say. So from this, keep this as equation 1. Guys, you can do anything, okay? Just solve it from first. Actually, initially I should have taken some expression as equation. Actually, I'm just solving and just saying how you should solve. But you should really include each and every step statements, because that is very, very important. Okay. So from this I got the sine per 4 theta plus cos of 4 theta is equal to 1 minus 2 sine square theta cos theta. Just apply it over here. Therefore, your LHS will be nothing but sine per 4 theta plus cos of 4 theta will be 1 minus divided by sine theta times of cos theta. Okay, wow. This is what I am having. So now what you will do? Now what you can do? What you can do is just simple, just split it out. 1 by sine theta cos theta into this expression by sine theta cos theta. Splitting up a minus b by c, I can write as a plus a by c minus b by c. Splitting, you guys know now, very simple. So therefore I can write this as 1 by sine theta cos theta will be c. I will write, yeah, okay, 1 by minus of 2 times, sorry, yeah, 2 only, 2 times of sine square theta divided by sine theta Okay, so this is what you will get when you split it. Okay, I'm just splitting this term like this. You can do now, very simple concept. I can't explain because you are 10 students. Okay, so now 1 by sin theta cos theta is secant theta cos theta. 2 sin square theta times cos theta by sin theta cos theta is 2 sin theta cos theta. That's all, we got it. So I will write here, okay. So no need, I will write, this is the expression that you will get. Write with steps, people, don't do like this in your exam. That is not they want. Like, write like your, this particular expression is equal to secant theta cos theta minus 2 sin theta cos theta, which implies that is equal to your LHS, hence proved. That is how you should write, because there is no space. I am writing like this. So this is how you should solve. 1 by sin theta cos theta is secant theta cos theta, 2 sin square theta by cos theta minus sin divided by sin theta cos theta is 2 sin theta cos theta, hence proved. Just write it like that. So that's all of this question. Let us move on to the next one. Our next question is, if 1 plus sin square theta is equal to 3 sin theta cos theta, prove that your tan theta is equal to 1 or 1 by 2. So people, this is not a thinking question, just you can solve it directly. So what you need to do is, it is given that your 1 plus sin square theta, I will write here, okay, 1 plus sin square theta is equal to 3 sin theta cos theta, correct or not? So in this particular equation, I am going to divide your sin square theta on both sides of the equation. I am going to divide your sin square theta on both sides of the equation. Therefore, I'll get it as okay, so this will be equal to 3 sin theta. Guys, I am solving it faster because you guys know it now. Very easy topic. Just you guys know, just you understand the approach. That's it. If you understand the approach, you can just solve it very easily. Okay. Actually, I'm speaking like this because I have a throat infection. So please adjust it. So now, when I divide a sin square theta on your both LHS and RHS, I'll get it as, I'll get it like this. Correct or not? So now, therefore, I can write it as 1 by sin square theta plus sin square theta by sin square theta, which will be nothing but is equal to 3 sin theta cos theta by sin square theta. So 1 sin theta and 1 sin theta can cancel. Therefore, I will be left out with sin theta in the denominator. So this will be nothing but 3 cos theta by sin theta. Correct or not? So now 1 by sin square theta is cosecant square theta plus 1. Correct or not? 1 by sin square theta is cosecant theta plus sin square theta by sin square theta is 1, which is equal to 3 times of what is your cos theta by sin theta? That is 3 times of cot theta. Okay, this is something I will be left out with. So now either you can convert cot theta to cos theta or cosecant theta to cot theta. Think carefully and say either I can convert your cot theta to cosecant theta or cosecant theta to cot theta. What I can do? Yeah, I can convert your cosecant square theta as 1 plus cot square theta. Okay, because I'm having square now, so it's difficult to convert your cot theta in terms of cosecant theta. Just simply I'm writing a cosecant square theta as 1 plus cot square theta, Pythagorean identity. 10 plus 1 is equal to 3 cot theta. Okay. Yeah, correct. So just take all your 3 cot theta to the LHS. So I will write here, okay. Therefore, I'll get it as cos square theta, because there's 1 cos square theta, 1 plus 1, that will be 2. Then I can take this 3 cot theta to the LHS. Therefore, I'll get it as 3 minus of 3 cot theta plus 2, because 1 plus 1 is 2. Okay, so this will be equal to 0. Now, this looks like a quadratic form. Okay, very simple. I just explained what I did here. Cos square theta I wrote here. This 3 cot theta I took to LHS, that will be minus 3 cot theta. Then plus 1 plus 1, that will be 2, which is equal to 0. So now, either you can take your cot theta is equal to some constant or t and solve the quadratic, or you can directly solve, no problem in that. Okay, so let me solve in the way that most people do. Cot theta is equal to t. If cot theta is equal to t, I can write the same quadratic equation as t square minus 3t plus 2 is equal to 0, which implies that, how I can write this? 2t minus 2 minus t. So t minus 2 into t minus 1, correct or not? Which is equal to 0. This is the quadratic form, factorized form that I will get. So therefore, your t is equal to 2 or 1. So 2 or 1. So what I took for t? I took your cot theta as t. So your cot theta will be equal to 2 or 1, which implies that what has been asked in the question? Prove that your tan theta is equal to 1 or 1 by 2. If cot theta is equal to 2 or 1, it is not divided by 1. I will write here, wait. So if your cot theta is equal to 2 or 1, what will be your tan theta? Take the reciprocal. So we'll take reciprocal. 1 by cot theta will be tan theta. That will be equal to, take reciprocal on this side also, 1 by 2 or 1 by 1, that is 1. So hence PROVED, proved. Okay, so this is how we need to solve this one. So if a cot theta is equal to 2 or 1, they are asking tan theta, take reciprocal on both sides. So 2 reciprocal 1 by 2, 1 reciprocal is 1 by 1, which is 1. That is what it's been asked to prove. So that's all. Now it's very easy. So I think we can solve one more last question, and that's a very good one. The next one is, prove that your 1 plus tan square a divided by 1 plus cot square a is equal to 1 minus tan a divided by 1 minus cot a the whole square, which is equal to tan square a. So basically, let me take this as your RHS. Okay, this is my methodology I am doing here. So let this expression be LHS 1 and let this expression be LHS 2. So this LHS 1 is equal to LHS 2 is equal to RHS. That is something we are supposed to prove here. So people, this is a very easy one it's very easy to prove your LHS1 is equal to RHS. So LHS1 is nothing but 1 plus tan square. What is 1 plus tan square theta? 1 plus tan square theta is cosecant square theta. Therefore there will be 1 plus tan square theta is cosecant square theta? No. Sorry. I wrote it wrongly. 1 plus tan square theta is secant square theta. Secant square A divided by 1 plus cos square A will be, this will be cosecant square A. Okay, sorry. That's a small mistake I did here. Okay, so this is how you can write this 1 plus tan square A and 1 plus cos square A, basic Pythagorean identity. So now the same LHS1 I can write it as C. What is secant square A? Nothing but 1 by cos square A. What is cosecant square A? That is 1 by sin square A. Basic formulas. So therefore, just by taking reciprocal, just inverse it out. Therefore, we'll get it as sin square A by cos square. You know now how it came. Very simple. 1 by cos square A, it will be 1 by sin square A. Sin square A to the numerator, cos square A to the denominator. That is what I did here. Which implies that the LHS1 is equal to sin square A plus cos square A is tan square A. Okay, 1 minute. Therefore, your LHS1 is tan square A. Hence, your LHS1 is proved. Okay. And now, we need to prove your LHS2. The job is not over. So, just stay with me. We need to prove that your LHS2 is equal to your RHS. So what is your LHS2? Your LHS2 is nothing but I'll write here 1 minus tan A by 1 minus tan A, it will be 1 minus cot A the whole square. So I can write this 1 minus tan A as, that is tan A as sin A by cos A, and your 1 minus cot A as 1 minus cos A by sin A. Correct or not? Then the whole square. Don't forget this. Sometimes most people do this mistake. So just observe what is given in the question. That is very important. Okay, so 1 minus sin A by cos A, it will be 1 minus cos A by sin A, the whole square. This I can write it as, just take the LCM, therefore LHS2. Nothing but, when you take LCM, you get this cos A minus sin A by divided by sin A by sin. This is what I will get. Take a LCM and both the numerator and denominator and then the whole square. Correct or not? Very simple task. So now what I am gonna do is, now you should be very careful because don't do any calculation mistakes now. So the whole square I am having, so I can write this as your numerator square by denominator square. Correct or not? So this I can write it as cos A minus sin A the whole square divided by cos A square will be cos square A, and this expression I can write as sin A the whole square by sin A the square, that is sin square A. This is what I will be getting now. Very simple now. Very simple task. So just I solve the square. Okay. So this expression I can write it as, what is your cos A minus sin A whole square? That is A square. That is A minus B whole square identity cos square A plus sin square A minus 2 sin A cos A divided by divided by sin a minus cos a whole square will be sin square a, that is a square, plus cos square a plus b square minus 2ab, that is minus 2 sin a cos a, correct or not, divided by your sin square. This is what I am having. Okay, just I solved your square using your basic identity. So what you can observe is these two terms are same, therefore I can cancel out. So therefore I'll get it as 1 by cos square a divided by 1 by sin square a, which implies that your LHS is 2. 1 second, wait. Which implies that your LHS 2 is equal to 1 by cos square a by 1 by sin square a. Therefore, I can write it as sin square a by cos square a, which is equal to tan square a. Hence proved. So that's all of the questions, people. That's all of the questions on today's session. So I will solve trigonometry today. I will solve many chapters in the upcoming days. So that's all of this video. I hope you guys have enjoyed. I hope you guys have enjoyed the question that I solved today, as well as the concept. Maybe someone can learn new concept, new approaches. That is what I also want. So that's all of this question. That's all of the questions on today's session. Thank you. Make education simple.